Okay, next up, you want the Lewis structure for CF2CCl2. A good way to quickly think about this one is, so we have C2F2Cl2. Let's say we consider the halogens hydrogen, then you'd have C2H4. And that, of course, is the general structure of an alkene. And so we can expect this to be an alkene with the hydrogen substituted for other things. And so this would be the very, very quick way to get the answer. If you want to go through the long process, you count your valence electrons. So we're going to have 2 by 4, 8, plus 2 by 7, 14, plus 2 by 7, 14. That is going to give us 28 plus 8, so we have 36 electrons to take care of. Let me just start with your skeleton. And one bond between each. Fill in the octets for your halogens. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So yes, electrons do make sense in this case, but we need to remember that carbon would need a filled octet too. Carbon likes to make 4 bonds, and so in this scenario, again, let's count out our valence electrons, and we have we have technically 8 by 4. So 8 by 4 plus 2, 4 plus 2. And that is going to give us 32 plus 4 plus 2, which is 38 electrons. So here we have too many electrons. And so we need to drop them down by moving some of the lone pairs into bonding pairs. So it would be tempting to do it on any of them, but we know halogens like to make 1 bond. All of them have already made their 1 bond. Carbon likes to make 4 bonds. Each of the carbons have only made 3 bonds. And so let's just make both carbons happy by giving them both the 4 bonds by creating a double bond between them. Now we double check our valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So our valence electrons are all taken care of. Let's double check on our formal charge. Cl is going to have 7 minus 6 minus 2 over 2 for both of them. This is going to give us 0. Fluorine is going to look the exact same, 7 minus 6 minus 2 over 2, 0. And lastly, the carbons are going to be 4 minus 0 minus 8 over 2. And that is also going to give us 0. This all makes sense. We expected a net formal charge of 0, so this is going to be our final structure here. Valence electrons are taken care of, formal charge is taken care of.